रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। औज़ु बिल्लाहि मिनश शैतानिर रजीम। बिस्मिल्लाहिर रहमानिर रहीम। Dear brothers and sisters in Islam, Assalamu alaikum wa rahmatullahi wa barakatuh. Subhanallah wa bihamdihi, Subhanallahil azim wa bihamdihi, astaghfirullah. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. My today's video topic is the barbecue of Tahir field equation 1a as in video 116, video 16 and 17. Okay, so rewriting Tahir field equation 1a, dv over dt is equal to d square r over dt square minus r d theta over dt whole square sine beta plus r d square theta over square means the second derivative, but it's very easy on the tongue, so that's why I call it square. Otherwise you can call it d2 theta over dt2, but doesn't convey too much sense otherwise. Okay, let's call it r d square theta over dt square plus r dr over dt d theta over dt plus dr over dt d theta over dt cos beta. In this video you will come to know why I put that top bar on this expression. It will become crystal clear. Okay, so plus dr over dt d theta over dt is equal to cos beta. So this is Tahir field equation 1a. Okay, so let us do some barbecue of this expression under the top bar. So rewriting the expression r d square theta over dt square plus dr over dt d theta over dt. So once again this is easy on the tongue, so I call it square, but actually it's not square, it's the representation of the second derivative of one function with respect to the other. So r d square theta over dt square plus dr over dt d theta over dt is equal to r d over dt d theta over dt plus dr over dt d theta over dt is equal to r d over dt. Okay, d theta over dt, as we know that v cos beta is equal to r d theta over dt, as gone in my previous video. So v square cos, okay, so dr over dt, so put the value of d theta over dt as v cos beta over r plus dr over dt d theta over dt. First take dr over dt is equal to v sine beta. So we will do the analysis with dr over dt is equal to v sine beta. Then we will do the analysis with dr over dt is equal to plus I v cos beta. And then we will do the same analysis in the same fashion with dr over dt is equal to minus iota v cos beta, whereas iota is the square root of minus 1, which is rotation out of plane of 90 degree. Okay, where were we? Okay, so same as above. So we have r d over dt. So we can multiply v cos beta by r. It will become h, because h, as in my previous video, is h is equal to r v cos beta and over r. So multiplying the numerator and denominator by r, we get h over r square plus v sine beta v cos beta. Dr over dt is v sine beta and d theta over dt is like from d theta over dt you can get from v cos beta divided by r. So you have v cos beta divided by r. So differentiating r h into minus 2r minus cube dr over dt plus v square sine, this becomes v square sine beta cos beta over r is equal to minus 2h r over r cube dr over dt. Now h contains r, so this is 1r, so we will left with 1r only in the denominator. So v square sine beta cos beta over r is equal to minus 2r square v cos beta over r square v sine beta plus v square sine beta cos beta over r. So this is minus 2 v square sine beta cos beta over r plus v square sine beta cos beta. So this becomes minus v square sine beta cos beta over r. So we can write dv over dt is equal to d square r over dt square minus v square cos square beta over r sine beta minus bracket minus v square sine beta sine square beta cos beta over r, which is this term, and it is equal to this term, and this term the same as this term. So and this term is the same as this term. So we get minus v square sine beta cos beta over r plus v square sine beta cos beta over r cos beta. Similarly, we can show that for dr over dt is equal to plus iota v cos beta, we have r, we will calculate the same term as the top bar. So r, like we did here. So r d square theta over dt square plus dr over dt d theta over dt is equal to minus. The only difference is gonna be here is that we will we'll get this expression from here, because there is no change in this expression. So same expression we'll put here, and here we have r3, so we will reduce it by 1r, so we'll get r squared. So dr over dt we will put here plus iota v cos beta, so we put minus 2 v cos beta r dot plus iota v cos beta. So this becomes minus 2 iota v square cos square beta over r. Okay, so you can also write is minus 2 times plus iota v square cos square beta, because plus sign is the sign with the rotation of 90 degree, which is iota, and it is not the algebraic sign. Right now we are considering two different things. One is the algebraic sign, the other is the rotation sign. Like iota is rotation, plus means rotation of 90 degree in one direction, and negative means the rotation of 90 degree in the other direction. So minus 2 plus iota v square cos square beta over r, I forgot to write it, r d square theta, it becomes, so r d square theta dt square plus blah 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 blah, the total term. Now this term is this term plus dr over dt plus into d theta over dt is this term. So we get minus plus 2 iota v square cos square beta over r plus iota, because this is the algebraic sign, this is the sign with the rotation, which we have considered here. Plus iota means rotation of 90 degree in a one direction. Okay, so this becomes this, so we get the same expression like this, except with iota term minus, and this cos term, sine term replaced by the cos term. So minus plus iota v square cos square beta over r plus iota v square cos square beta over r. Okay, so we can also write dv over dt is equal to iota square. If we take minus 1 common here, which is minus 1 is equal to iota square rotation of 180 degree. So iota square v square cos square beta over r minus d square r over dt square sine beta, plus, then we write these two terms, minus plus iota v square cos square beta over r plus iota v square cos square beta over r into cos beta. So we can write dv over dt is equal to iota square, which is rotation of 180 degree, minus d square r over dt square sine beta, plus bracket minus iota v square cos square beta over r plus minus I v square cos square beta over r cos beta. So this is the expression dv over dt, which we get by using this combination dr over dt is equal to minus 3 minus iota v cos beta, and this is the expression. So this is the expression that we get from here by using minus iota v cos beta. And this is the expression that we get when we use dr over dt is equal to v sine beta. I didn't have too much space on the board, so that's why a little bit congested. So we can write dv over dt is equal to this cos theta. Now it is time to mix both the algebraic sign and the rotational signs for clarity. Algebraic and rotation of 90 degree signs, we obtain dv over dt is equal to iota square v square cos square beta over r minus d square r over dt square sine beta, plus minus iota v square cos square beta over r plus iota v square cos square beta over r minus v square sine beta cos beta over r plus v square sine beta, which is from here. So this part, these two terms from here or here, and these two terms from here. Okay, so we can write dv over dt is equal to iota square blah blah blah. Okay, so this one is here. So why we have written, because there is a rule in algebra, if c is equal to a and c is equal to b, then c is equal to a plus b. So we have added this equation, c is equal to a, and then c is equal to b. So c is equal to a plus b. So a is this part and b is this part. This you can consider as constant, because it's the same in both the equations. So I have 3 inertial couples of forces, or total 6 forces acting on a particle of mass m going with constant velocity in straight line in inertia in matter-free space, as I discussed in my video number 1, the first video that I made. So we have 3 couples of inertial forces acting on a mass of particle m going in deep space where there is no matter, with constant velocity. If the velocity is 0, then definitely the body is at absolute rest. Okay, so plus minus v square, which is not possible except with the Almighty, because matter is attracting other matter in the entire universe. So plus minus v square, v square, I will also discuss this in my later videos. So plus minus v square cos square beta over r minus d square r over dt square is the first couple of forces. One in this direction, which I have shown in this diagram. Let's say the positive is centripetal, so it is focused towards one focus, because two particles, they are attracted with respect to the common focus. or called the Tahir center of rotation. So this is v square cos square beta over r minus d square r over dt square. I've shown with this arrow a little bit separated from the radial distance so that reader does not get confused, because this is the radial distance from the focus of this mass m. The focus does not contain any mass, just reference, hypothetical. Okay, so we'll consider, when we consider two masses, we'll discuss. Okay, so this is the mass. Okay, so one couple is this. So this couple is this v square cos square beta over r minus d square r over dt square, and the other force of the couple is this v square cos square beta over r minus d square r over dt square. Look here. First force v square cos square beta over r minus. The second force is the rotation 180 degree of the first force. First force is this. The second force is this. So this expression is very, very tricky expression. You got to be very careful. The first force is this force, and the second force includes iota square. So meaning the rotation. So when we show directions on a diagram, we never show the signs, because we have already shown the direction, and directions automatically include signs. Otherwise, it will be unnecessarily complicated and confusing for the reader and the viewer. Okay, so one couple is v square cos square beta over r minus d square r over dt square, and the other is v square, same value. The value is the same. Only difference is the direction. The direction is 180 degree apart. So this angle is 180 degree. So and the second couple is in the same plane. This couple v square cos square beta over r minus d square r over dt square is in the xy plane. Similarly, this couple v square sine beta cos beta over r, and this same force, because one force is in one direction, the other force is separated by a negative sign, meaning 180 degree rotation. So this angle is also 180 degrees. So one couple in the same xy plane is v square. One force of the couple is v square sine beta cos beta over r, and the other is this v square sine beta cos beta over r, and both are at 90 degree to the, because sine beta and cos beta means angle of 90 degree. With this couple, these couples are at, both couples, this one and this one, are both at 90 degree. The only difference is that the v square cos square beta over r is out of the plane and in the direction of the z axis. So one force of the couple v square cos square beta over r is, let's say, in the upward direction. We won't put sign because we have already shown directions in the positive z and the negative z direction, or in the negative x or in the negative y directions. So no need for signs. Signs will just confuse. Because we are using directions. So this force is v square cos square beta over r. This couple v square cos square beta over r, v square cos square beta over r, is out of the plane of the other two couples, v square cos square beta over r minus d square r over dt square, v square cos square beta over r minus d square r over dt square. So we have, when a particle is going, and this is the velocity of the particle v, and it's got a mass m. The particle is going like this. When the particle is going in matter-free space, in inertia, in deep space where there is no matter, then three couples act on it. This cancels this force cancels this force cancels this. So the net force on the particle going with constant velocity in inertia and deep space, in matter-free space, is 0. So we have Tahirian couples of inertial forces. Okay, so this one is perpendicular to the plane containing the other two couples plus other two couples. Which one? This couple and this couple. So this couple of forces is perpendicular to the plane containing this couple and this couple. This couple I will call Tahirian inertial couple of centrifugal and centripetal force. One of in my next video, I will when I will do the analysis of gravitation, I will show you how one is centripetal and the other is centrifugal. Okay. So, and this force is called Tahir force, v square cos square beta over r, and it is mutually perpendicular to the forces to the plane containing the other two couples. So v square cos square beta over r, v square cos square beta over r is the Tahir force. So I will show in, I have already shown in one of my videos on super elevation banking of roads, that how this Tahir force acts on a super elevated bank, on a vehicle going on a super elevated bank, how this force acts. You can watch my video on super elevation design of highways and motorways. Okay, so v cos beta is equal to r d theta over dt, v square cos square beta over r is equal to r d theta over dt square. And this is my book, Natural Theory of Relativity, Inertia, Gravitation and Gravitivity on the Shoulders of Tahir by Fayaz Tahir. So you can buy my book if you want to get everything in just one go. Otherwise, you have to wait till the very end. And sky is the limit, you know that. Why? Because if C is equal to A and C is equal to B, then C is equal to A plus B. Even if it contains a constant like this constant, it will be added once. It will not be added twice. Why? Because it comes in both C is equal to A plus K or C is equal to B plus K. So C is equal to K plus A plus B. Okay. Subhanallah wa bihamdihi, Subhanallahil azim wa bihamdihi, astaghfirullah. Allahumma salli ala Muhammadin wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. Allahumma hasibna hisaban yasira. Thanks for watching.